in this lecture I would like to touch upon a very important concept which is used widely in the internet nowadays. You must have heard about the term client server concept, client server programming. In fact, most of the internet applications that we see today, that we use today, they are based on this kind of client server programming. So, first I will try to explain what this client server programming concept is all about, then we shall be specifically looking at some of the applications of the internet. So, client server concepts and some of the applications are the topic of our discussion today. So, first see what the client server model is all about. This is a standard model for developing network applications today. Now, as the name implies, there is the notion of a client, there is the notion of a server. The basic idea is that a server is a program, or which is sometimes called a process. A program in execution is called a process. A server is a process which is continuously running and it wants to offer some services to clients. A client in contrast is another process which is requesting the service from a server. Well, as a simple example, the server may simply return with the date and time, the current date and current time. The client can ask the server, what is the date and time, please tell me. The server can return back with the date and time. This can be a very simple example. In general, a server can provide any kind of service and a client is somebody who is asking for that service. Okay? This is the difference between client and server. And in general, since we are talking about a networking environment, the server and the client may not be running on the same machine, they may be on different computers altogether. Typically, server is the program which starts first and server waits for requests from clients. So, as and when the requests come from client, the server will service them and will again go back and wait for some more requests from the clients. Okay. So, pictorially this looks like this. There can be one server, there can be several clients which can need the service, and we shall see later there are different ways of handling these requests in case there are simultaneous requests coming. Okay. Typical scenario, as I had mentioned, that the server should be the first process to start. In the typical scenario, first the server process must start on some system. The server process must initialize itself and then it goes to sleep waiting for a client request. See, sleep is a terminology which is used in operating system. It means that it basically goes to the waiting state. It is not executing anything right now, but it is waiting for a request from a client. If that event occurs, that means a request from a client comes, then the server program will wake up and it will start executing. So, if you remember or recall the typical state transition diagram of a process, that ready, running, blocked, then possibly the server process will be in the blocked state. It will be waiting for a request from the client to come in order to move into ready. Okay. Then a client process will start. Well, it can be in the same system, it can be on some other system, and it can send a request to the server. So, the server will obviously process the request. So, when the server has finished providing the service, the server can go back to sleep waiting for the next client request, and this process will repeat indefinitely as long as you do not explicitly shut down the server. This is a very simple scenario. Server is waiting, clients are sending requests, the server will be servicing the requests, it will be sending back the response, and this will go on. Okay. Now, typically the roles of the client and server processes are asymmetric. See, asymmetric in terms of the roles as well as when you write the actual client and server programs, these programs you may be writing in a language like C or C++ or maybe in Java or any language, you will find that the way you write the client program, the way you write the server program, there are some places where they differ. That is why they are called asymmetric, they are not symmetrical. If the client and server program looked exactly the same, then they would have said to be symmetrical, but they are asymmetric. Now, in terms of the exact way the requests are processed by the server, servers can be categorized as either iterative or concurrent. Now, let us see what these two mean. A server is said to be iterative when, first thing is that the server process knows in advance how long it takes to handle its request. Typically, this kind of server are used only when the service time is fairly small. If the request service time can be fairly long, this is not a good solution. Okay, this is not a good alternative. Typically, iterative servers are used in cases where the service times for the client requests are fairly small in time. So, single copy of the server will run at all times, and the server will process one client request at a time. The server will handle each request itself. Since it is a single copy, then only one request can be handled at a time. So, if there are 5 clients which are sending requests at the same time, the first one that the server receives will be handled first, the other 4 will have to wait. As soon as the server is finished with the first, is ready with the next request in queue will come and the others will wait. So, in this way it will go on. So, one request is being serviced or processed at a time, and all other clients which have also sent requests will be waiting. This is how it works. So, the client may have to wait if the server is busy processing other requests. Now, in contrast, concurrent servers work in a different way. They are typically used when the amount of work required to handle a request is unknown. So, you really do not know how long the client process will engage the server in providing the result of the request. Some requests may take much longer time. Say, I am giving a simple example. You can think of an application like a railway reservation system. Suppose whenever an operator turns on the system and connects to the server, say after 3 hours he shuts down the connection. Maybe for this entire 3 hours the client remains connected to the server, and whatever request is going, the server is servicing immediately. So, this is a long term connection, or you can say request processing scenario. Here you cannot handle the request in an iterative way, but here what is done is that whenever a client request comes, the server starts another process to handle each request, which means that a copy of the server caters to a client's request in a dedicated fashion, as many copies of server as there are client requests. See, here the scenario is like this. Originally there was one server which was waiting for client request. Say client A sends a request. So, what the server will do? Server will make a copy of itself and will allocate that copy to cater to the request of client A in a dedicated fashion, and the server itself will go back and wait for another request. Now, a request from client B comes, the server again makes a copy of itself and asks that copy to service request from B, and so on. So, in this way the thing will go on. If there are 10 requests coming simultaneously, there will be 10 copies of the server. Now, this may seem to be a little complex, that means how these copies are created, but if you know some of the details about process management in an operating system, you will know that almost in all operating systems there are some functions which you can use to create new processes. Like for example, if you are using the Unix or the Linux system, there is a function called fork, that is a system call. Now suppose you are writing a program in C, if there is a function called fork in the C program, so whenever that is executed, there is another copy of the process that gets created. So effectively concurrent servers uses this fork kind of calls to create multiple copies of itself. Okay. Now whatever I said is the basic concept behind client and server. Now how it actually works? Well, the client server communication can use either TCP or UDP depending on your requirement. Now if it is TCP, then before start of communication a connection has to be established, but if it is UDP, of course you do not need. See, when we talk about a connection, we must first understand what do we mean by a connection. See, suppose there are two computers on two sides, one out here, one out here. This is your source, this is your destination, and you want to establish a connection between S and D. Well, this can be a two-way communication in general. Now there are a few things you need to know about this communication, like which protocol are you using? Are you using TCP? Are you using UDP or something else, some new protocol? What is the IP address of the source? What is the IP address of the destination? And also, as I had mentioned that in both the source and destination sides there can be multiple programs which are running. So the port number specifies exactly which program the packet is destined to or is coming from. So you can have the source port number and destination port number also. So when you have all these 5 components known to you, you know exactly what is going on. You know exactly what protocol is being used. You know exactly which program out here is talking to which program out here. Okay. Now you can say that a connection has exactly been established, actually been established between these two programs, right. So these 5 components will constitute a connection. Now typically when you develop a network application, it is always advisable to use some standard and well accepted protocols, because if you follow some standard you will often get support from the software tools that we use in developing the software. Now here I am showing a very typical scenario. Say whenever one wants to develop an internet application, usually at the data link layer level you have the Ethernet protocol in most of the LANs we see. In the network layer it has to be IP, at the transport layer it can be TCP, and when you are developing the application, if you are using TCP and IP, then there are some standard application programming interfaces or APIs which are available. One very popular API is called the so called Berkeley socket interface. Now if you are using Berkeley socket interface, you will be having access to some functions which if you call, using that you can actually establish a connection between a client and a server. You can actually send a packet, you can receive a packet, you can do whatever you want. So you will have to understand what these functions are and how to use them. Once you know that, you can very easily write such an application. Now the basic concept behind the Berkeley socket, which is part of the so called Berkeley socket distribution BSD or Berkeley standard distribution, is called the socket. Socket is the basic concept behind inter-process communication over the network between client and the server. Basically the concept of socket allows one process to communicate with another. Now this one process can be the client, the other process can be the server. They may be on the same machine, they can be on different machines. Now, an analogy is like the telephone line. You can establish a connection over the telephone to allow one person to talk to another. Similarly, socket is an analogy to the telephone connection. Using socket, you can establish the connection, then client can send something, the server will receive, the server can send back something, the client will receive. In this way, a two-way communication can start. Now, from the socket point of view, there is a term called full association, which refers to that same 5 tuple I referred to earlier: protocol, local IP address, local port number, remote IP address, remote port number. All these 5 things taken together is called an association. And technically speaking, socket is defined as a so called half association. Like you have the two sides, one is the source, other is the destination. Now, if we have complete information about one of the sides, that is called a socket. Like either if you have the protocol, local IP address, the local port number, that is also a socket on one side, on the side of the source. If you have protocol, remote IP address, remote port number, then you have the socket on the side of the destination. So, the source opens a socket, the destination opens a socket, then there are some functions using which they communicate and establish a full association among the sockets. This is how it actually works. But in order to actually understand how it works, you will have to look into these functions in depth, and we will actually study how this client server programming can be done. But I am not going into the details of the coding and the details of the function, because these are slightly out of the scope of the present lecture. But if you are interested, you can certainly look into the details of the Berkeley socket interface, what kind of functions are available, and how you can utilize those functions to write client and server programs, both in the connection oriented, that means using TCP, or in the connectionless, which means the UDP environments. Okay. So, my purpose of telling all these things was to give you a rough idea about what this client server concept is all about. And I told you all the internet applications that you see, they are all based on the client server concept. Now, I would start with one of the most important applications, which, well, in itself is not an independent application, but is used by many other practical applications. That is the so called domain name system, or DNS. This you may have heard. This is a very important service which is provided in the internet, in LANs, in different areas. Basically, the domain name system is a global database system for internet addressing, mail, other info. See here, this need not be restricted to internet addressing mail. It can refer to World Wide Web, Telnet, FTP, any kind of application you use today. You typically use a name, you do not always use an address. The purpose of the DNS essentially is to convert from a name into an address. Okay. So, this is how it works. Now, the advantage of using DNS is that, see, using names rather than addresses is much easier to use, easier to memorize. Like for example, I am giving you one practical you can say example. Say the mail server of the Computer Science and Engineering Department of IIT Kharagpur, that can be referred to by a name CSE. The full name is cse.iitkgp.ernet.in. Well, you are familiar with names of this type. Now, this kind of a name is easier to memorize, but I also know that the IP address of the CSE machine is 144.16.192.57. Of course, you cannot remember many such addresses with numbers, you may tend to forget, but using names is much more easier because it is more English like, more easy to memorize. Okay. Now, in the domain name system, there is a concept of domains and subdomains. Actually, domain refers to a set of computers which are related in some way. There are some computers which are related either by their location. Location means I am talking about geographical location. They may be, I can say, all computers in India, all computers in IIT Kharagpur. These are some examples. These are some categorization of subdomains based on their location. And I can also specify these computers based on the way they are used or their function. Like I can say that, well, all computers which are in the educational institutions, all computers which refer to commercial organizations, these are example of distinction from the functional point of view. Okay. So, as I had mentioned that DNS servers basically translate domain names to IP addresses. This is the basic task, and this thing is done in a distributed system because of the simple reason, because one server in one place cannot have information about all the domain names in the whole world. There are millions and millions of such domain names and the corresponding addresses. You cannot expect that there will be one single server available in one place where you can get all the information. Rather, this has to be some kind of a distributed, you can say, database where information is spread across a number of different computers. So, just using some systematic algorithm, these computers can interact among themselves to get, means whatever you can say result you want to get. Given a DNS, a name, say name, you can get an IP address by systematic querying of these multiple server in a particular order. We shall see how these orders would be shortly, but before that let us talk about something called top level domains. Well, this you may be aware that the addresses you write, for example, yahoo.com, say something.gov, something.edu, stanford.edu, in refers to India, say earnet.in. See, these are called top level domain. When you write an address, like for example, when I write say www.yahoo.com, the last part that I write, that is called the top level domain. Now, top level domain can be one of many. I have only shown a few. Out of them, some of these are based on functional classification. Com means commercial or commercial organization, org means non-profit, net means network service provider, gov traditionally it stands for US government, mil military, edu educational. Now, in addition to this, there are 2-letter domains for each and every country of the world. For example, PK stands for Pakistan. There is a code for each and every country. This IN stands for India. Okay. This NZ stands for New Zealand. TW stands for Taiwan, and so on. Now, the domain name structure is a hierarchy. I am giving an example. So, I talked about the address of our mail server in the computer science and engineering department. See, the address has 4 different parts: CAC, IIT KGP, Unnet, in. Well, if you look from the other side, from the side of in, this in is a subdomain. This in refers to all computers in India. This ERNet is a subclass inside India. Now, within India there can be other subclasses also. There can be NIC, there can be VSNL, there can be others also. Okay. So, ERNet is a subdomain that is inside India. Again, inside ERNet you have IIT KGP. So within your net you have IIT KGP, IIT Bombay, you can have others also as well. I have not shown all, I have shown only 2. Then inside IIT KGP you can have computer science engineering, electronics communication engineering, mechanical engineering. Then within IIT Bombay you can again have computer science engineering, math and so on. So you can see that when you give a domain name, this is an example of a so called fully qualified domain name. Fully qualified means starting from the top level domain, I am specifying the entire path of the subdomains that you should traverse to arrive at the particular place that you want to come. Okay, I want to refer to CAC, I have specified in ARNet, IIT KGP and then CAC. So these are examples of domains and subdomains. Okay. So as I had mentioned that domain distribution is, or domain name management is not in one place, it is distributed. For example, IIT KGP domain name server can only keep information about the names that are under IIT KGP like CAC, EC, MEC and so on. Domain name system of ARNet can only keep track of all the institutions that are under ARNet like IIT KGP, IIT Bombay, IIT Delhi and other institutions. Similarly, domain name India can keep track of all those ISPs that are inside India like ARNet, NIC, VSNL and so on. So in each of these tables you have only those entries that are immediately under it. There is a big domain, there are smaller subdomains under it, and each of these subdomains again they will be having smaller subdomains under them. So each of this domain will contain information only about the subdomains that are immediately under it. This is how the domain name server information is distributed. So effectively DNS server will store the domain name and the IP address. They will store information only about the computers that are immediately under them. Okay. Just to have a quick look at statistics, this is only up to the year 1995. You can just imagine how it has grown since. These are the figures in thousands. The number of computers in the .com domain in 1991 it was about 2 lakhs. In 1995 it is about 2.4 million. Similarly, education institutions from 250,000 it has gone to about 1.7 million. So you can just imagine the rate in which the number of computers are growing. Okay. So the number of such domain, subdomain and these names are growing. Okay. Now DNS server converts an IP address, converts a domain name into an IP address. Now let us see how this is actually done and how these domain name servers are called or where they are kept. Now the most common domain name server is Berkeley Internet Name Domain. In short it is called BIND, BIND. For instance, if you are using a Unix or a Linux system, you will find that there is a process whose name is named. The Berkeley Internet Name Domain server runs as a process called named. This is the actual name server process. When an application, it can be Telnet, FTP, web, mail, anything, when it wants to get some information from the server, it can invoke the so called DNS name resolver. See, the bind program is already running, that is the server program. The client program is separate. The client program will be used to send a request to the server program. So there is one popular client program, this is called NSLOOKUP. So if you run NSLOOKUP on any system, it can be a Windows system, it can be a Linux system, whatever. So that if you run this NSLOOKUP, then what will happen, it will ask you to type in the domain name. Well, it has to be the fully qualified domain name starting from the top level, and this NSLOOKUP will be actually contacting the name server and it will get translated into the IP address, and the IP address will be returned back to you. So, either in the Unix or Linux scenario or in the Windows environment, wherever, if you give a command ns lookup, say if you are using the Windows environment, you can give it from that run prompt or through a command prompt, then you will find that it will be asking you to type a domain name. You type a domain name www.yahoo.com, return. You will find that after some time it will return you back with the IP address of that yahoo.com. Okay, this is how it works. But as I mentioned that the name server that is running, it cannot have all the information. Well, and in general it will not have the information locally. In that case, every name server has a connection with a so called primary name server, which means if we have a name server out here, this is your name server. If it does not have an information, then it will contact a primary name server. Now you can configure that which will be the primary name server for your case. Okay, and in case the primary name server is not available, you can also specify some secondary name server. Okay, some other name server also you can specify, secondary name server. So if the primary is not accessible, you can contact the secondary name server. But the point to note is that, well, whether you contact the primary or secondary, that is not important. Important thing is that information is not available in one place. You have to look into other places if you do not have the information, for example in your primary name server. I am giving an example. In our institute there is one primary name server available. So in all our computers we have set, means I have also set it in my computer, set the primary name server to be that particular machine. So whenever we type in some name, some domain name, that domain name gets transferred to that primary name server with a request for the IP address. If it is available in its local table, it immediately sends back. Otherwise, it sends back to its primary name server, because if you look at that primary name server, that is also not knowing everything. So with respect to that particular machine, there will be some other primary name server who it will ask if it does not have the information there. Okay, so everyone will be having a link to some other name server till you reach the absolute top level name server. From there it can again come down. So I will give a small example. This diagram gives you the so called hierarchy of name server. Say at the top you have a virtual root level name server. Say I have taken some examples. I have taken two education institutions, Stanford and Georgia Tech, and two commercial sites, Rediff and Yahoo. Stanford and GATEC will be connected to a name server under edu. They will be connected with a name server under com. If you have Indian companies, they will be under the India IN name server. If you have Australian companies, they will be having under AU, so on. So this is how name servers are organized. This root will contain information about all the top level domains. This edu will contain information about all the universities under this edu. This com will contain all the .com companies. Okay, this is how the domain name information are distributed. Now let us see how this name resolution takes place. Well, here let us take an example. Suppose here we have a client and we want to get the IP address of yahoo.com, say, and the client is a machine which is connected to the stanford.edu site. So the client will first send a request to the stanford.edu name server. The stanford.edu name server will find that the information is not available with stanford.edu, so it will be sending the request up to the edu name server. Well, edu will also find that, well, yahoo.com is not in my table. So, this edu web server will also send it one level up to the root name server. So, root name server will tell, well, yes, I know what com is somewhere here. So, it will forward that request to the com name server. Finally, com name server will know, well, yes, I know yahoo.com is here. So, from here you can get back the actual IP address. Once the IP address is obtained, this is the so called recursive name resolution. The response, that means the actual IP address which you have found out, this will be following the exact reverse path with respect to the original request. So, you see that so many message exchanges are required to get back the IP address of the name that you had requested for. This is the requested name resolution process, and here say with respect to the client, if you send out one request, exactly one response is being sent back. So, just if I am the client, if I am a client means I am on a computer, I am typing some name, say www.yahoo.com. So, from my computer exactly one request will go out and exactly one response will come back. So, beyond that what is happening, that I am unable to see, that I am not seeing. So, but if it is recursive name resolution, then there are lot of message transmissions that are going on from one name server to other in order to resolve the name. Okay. There is another alternative, it is called iterative. Iterative says that the client will sequentially send queries to DNS server. Like for example, this was the client. The client first sends a request to the say stanford.edu name server. Stanford.edu name server will be sending back a response saying that, well, I do not have the information, but you can contact edu. So, it will send back another request to the edu name server. The edu name server will be sending back another request saying that, well, I do not have, root may be having. So, it will be sending another request to the root. So, in this way the client has the responsibility of sending the requests, getting the response, sending the next request and so on. So, the responses that the client is getting back in this case will contain which name server I can contact next, or in the final case I have got the IP address finally. So, this iterative name server is easier to implement, that is why most of the systems they implement this iterative name server process. So, the client will sequentially send request. So, if the response is negative, it is not found, then the corresponding DNS server will be sending back that which server to query next. Okay. So, unlike recursive name server where only one response is being sent back to the client, here you can have multiple requests going out and multiple responses coming in to the client. Okay. Now, this name resolution or this DNS protocol is central to any internet application. Okay. Now we talk about some of the internet applications which may be using DNS for their use. Two of the protocols we would be discussing as part of today's lecture. The first one is the so called Telnet protocol. Telnet is one of the oldest protocols that have been in use even before the internet took its shape. This Telnet command or the Telnet facility was available. Subsequently, Telnet has become an internet standard. The idea of Telnet is that it allows a person sitting on one computer to work on another computer. Like for example, I am sitting on this computer A and I want to start using computer B over the network. What I do, I give a command from A. The command looks like this: telnet followed by the address of the computer in which I want to work. Well, here I can either specify the name, or if I remember the IP address, I can also specify the IP address. Now, once I do a telnet from A to B, well, obviously I am trying to start a remote session, and usually there is some authentication where I am, if I am sitting at A, I will have to supply a valid login name and password corresponding to machine B to gain entry. So, sitting on machine A, I give a telnet B, and on the screen I find some username password coming, I type in those things, I gain entry into machine B. Now, whatever I see is the screen corresponding to machine B. If I give a directory listing, I can see the files which are there on machine B. If I run if I say for example run a command like C compiler or anything, if I run a command is not running on my computer, rather the command is running on the computer B. But what is happening, whatever is the output of that command, somehow that output is coming on my screen. So, as if I am having an illusion that I am actually sitting on the computer B. Okay? This is a very useful facility, particularly in a network environment where you do not have everything on your computer. Something may be available on some other computer, you can do a telnet and use it. Okay? Fine. So, some typical applications. Telnet can be used to use software which is only available on a central server, for example. Another application, suppose you have a printer attached to one computer, so you want to take some printout. So, you can do a telnet to that remote machine, remote host, and then you can give a print command. So, a typical scenario in a laboratory environment is that many users who are typically students do a telnet to a remote server and work there. Server is actually a bigger and faster computer. Now, the advantage of this is that instead of loading the software all the students are wanting to use on all their computers, you are loading them in only one central place. It also simplifies a lot the maintenance of the software, that means how they are using, what they are using, and if you want to change the software to a new version, you need to do this change only in one place. Okay? So, telnet is a very useful command. Now, by default the telnet server runs on port number 23, which means whenever you give a command like telnet something, telnet say means a machine name XYZ, then a TCP connection is established with the machine TCP with the machine XYZ over port number 23. 23 is a standard for telnet, which is the default port number which is used. But in fact, this telnet command can be used to specify any other port number as well. How? Like this. I can do a telnet to any machine by specifying the name, but at the end, as an optional parameter, I can also specify the port number. Now, you will learn later that this port number 25 is actually the port number which is used by the mail servers. So, when I do a telnet to this machine over the port number 25, what I am trying to do is that I am actually trying to contact the mail server directly. Okay? There are many cases or many applications where you may want to do this. Well, we shall be talking about this in more detail when you talk about the electronic mail system later. There you will see that we can actually do a telnet to connect to a mail server, and you can actually send and receive mails through that facility. Okay. Just to show you a sample telnet session, this is an example which I have taken from a Linux system. This was the original Linux prompt, Sunny. This is the command which was given, telnet CAC. See, once this telnet CAC was given, CAC was a name, so automatically the domain name system was contacted and the name CAC was translated into the corresponding IP address, but as a user I do not see that happening, it is happening in the background automatically. So even if I have given Telnet CAC, I am seeing that some IP address is coming trying to contact 142.168.192.57. This is the IP address of the CAC. So finally after connection is done, some message is coming connected to CAC. This is the message which is coming from the Telnet server on the CAC side. Some other message is coming, ignore these things, some Linux version etc. coming. Then a prompt is coming asking me to supply the login name. So I supply the login name here. A prompt is coming to supply the password. Well, I supply the password here, but this is not visible because passwords are normally not visible on the screen. So if my username and password are correct, some welcome messages come right here, last login this, Linux this, you have new mail, and this is the prompt which is the prompt of the CAC machine. So now I can give some commands where the responses will be coming from the CAC machine and not from the Sunny machine. So this is just a simple example I have shown that how we can use Telnet to connect to a new or remote machine. Okay. Now we talk about another protocol called FTP. See, using Telnet we are able to log on to another system and use some facility out there, but what we cannot do in Telnet is that we cannot physically transfer a file from one machine to another. We cannot bring a file from that machine to my machine, or I cannot send a file from my machine to that machine. For that purpose you need to use a protocol called FTP or file transfer protocol. So let us see what FTP is. Now FTP allows a person to transfer file, as I said, between two machines. Just exactly like Telnet, to provide authentication you need to supply login name and password, because if this was not so, then anybody can transfer any file across any machines. That is not what you always want. There has to be some security also. Some files you do not want anyone to access. Only persons who are having a valid account, login name, password can only access. So this kind of login name and password authentication has to be there. And the command is very simple, very similar to Telnet, FTP name or FTP IP address. Okay. Now anonymous FTP is a variation of FTP which had become very popular in the early days of the internet. Now see, the conventional FTP requires a user to supply a username and a password. But suppose on my machine I have kept a number of information, useful files which many people may want. But how many people have access to my machine? They do not have a valid username and password, many of them in fact. So this anonymous FTP is a mechanism using which anyone who is sitting anywhere in the world can come to my machine and take some files from me. Okay. Here the idea is very simple. Whenever the system asks for the login name, you type the string anonymous instead of a valid login name, and when it asks for the password, you type your email address. Then whenever you type the login name as anonymous and your password as your email address, then you get logged in as an anonymous user. In that FTP server there may be a whole lot of files available for the anonymous user for downloading. So now you can have a look at the files, you can list it, you can get the files that you need. In fact, this anonymous FTP is in the early days of the internet was one reason that internet became so popular. There are many good people who wanted to share information. They kept a lot of information on their servers, and using that they basically allowed other people to share. So, the huge amount of resources were available in anonymous FTP sites. Now, the FTP process model looks like this. Suppose this is a client which gives the FTP command, and this is the server on which the FTP server is working. Okay. Now, in fact, FTP uses two port numbers. Port number 21 is standard, and this 22 can be anything. In fact, this can be anything, but port number 21 is must. Okay. There are two connections which are established. One is called the control connection. Through the control connection is established over port number 21. So, the FTP connection gets established. Now, after the control connection, whenever you want to transfer a data, so a data connection will be established every time you transfer a data, and that data connection can be opened over any port number. Here as an example I have shown 22, but it can be 1000, 2000, 3000, anything, but this port number 21 is standard. So, the idea is that if you do a telnet, and if I want to transfer 5 files, there will be 5 data connections opened and closed one after the other. For every single file transfer, a data connection will be opened, and after the transfer is complete, it will again be closed. Okay. So, this is what I said, two connections established. One is the control connection over port 21, and control connection remains all throughout a session until or unless you log out of that FTP, and the other port number is a temporary port number used for every file being transferred. As I said, for every file transfer you establish new connection. Okay. And some typical FTP commands, there are many commands, I have shown only a few. Put or import. Put means send one file, import means multiple put. Get or mget, receive a file or multiple file. Hash, if before put or import you give the hash command, you can see the progress of the file transfer. Some symbols are getting displayed one after the other. Now, each symbol typically display shows either 4 kilobytes or 8 kilobytes of data transfer. So, you can see the hashes coming one after the other. You can see that, well, my file transfer is in progress. Okay. Prompt, it prompts a user before they transfer whether you really want to transfer, yes, no, like that. It asks you whether the file you want to transfer is a binary file or a text file, ASCII file. Exit means it terminates, exits the FTP server. Well, some example session, let us say. Suppose here again we are setting on a machine called Sunny. From there I want to do an FTP into another machine whose name is say CAC Indigo. So, connected to CAC Indigo, the connection over the control connection is established. See, some response codes are coming, say 220, some I say 331, 230. These are some intermediate response codes followed by the actual response. See, when this connection is done, then this 220 means that the connection is successful. Then it asks for the username, then it asks for the password. This 331, anything which ends with 1, this means this is an intermediate completion reply. So, this username password thing is not yet complete, it is halfway through. So, once this authentication is done, it responds at 230, it ends with 0 means it is the end of one step. So, now you see a prompt FTP comes. Now you can give the FTP commands. Like one small example I have given, if I give a dir command, it means directory. So, I can see a list of all the files which are there in the other computer. Okay. So, I can say list of all the files, their sizes, how big they are, and so on. So, if I choose to transfer any one of these files, I can give a command. Say I want to transfer this file, land csfig get this file name. So, it opens a new connection, it also tells you that 671 bytes received, transfer complete. Then I can terminate the connection by this quit. So, connection gets terminated. Okay. So, this shows the sample FTP session how you can use it. So, this brings me to the end of the today's lecture. Before ending today, let me have a quick look at the solutions to the quiz questions of last lecture. First question was, what are the 4 types of BGP messages? They are open, update, keep alive and notification. How is a BGP connection between 2 routers maintained? As I had mentioned, by periodically exchanging keep alive messages. What are the main functional procedures in BGP? Neighbor acquisition, network reachability. Why is IPv4 not suitable for supporting real-time traffic? Because they are based on datagram, they do not guarantee that packets will follow the same path. Okay? So, there will be unequal delays in the packet and there can also be out of order delivery, for which real-time response is not possible. How are the headers in an IPv6 packet kept track of? So, all extension headers after the base header are chained in a linked list. This I had mentioned. How does IPv6 attempt to support real-time traffic? IPv6 allows a pair of stations to establish a path before sending packets. So, this is an option you have in IPv6 to support real-time traffic. What does the payload length signify? They specify the length of the extension headers and the transport level protocol data unit in an IPv6 packet. What does the next header field mean? The type of information that immediately follows the correct header, the current header. So, there can be multiple headers or the PDU. So, the next header will contain what is following the present header. In IPv6, how are the fragments kept track of in case the packet is fragmented? First thing is that base header is copied into all the fragments, and if there is a fragment header in one packet, it means that it is fragmented. So, there has to be fragment header in all the fragments. What is anycast addressing? Packet will be delivered to exactly one of a set of computers. How can you use tunneling to send IPv6 over IPv4? The entire IPv6 packet is encapsulated as payload, and IPv4 header will be added to it. So, now some questions from today's lecture. What is an iterative server? What is a concurrent server? Which of client or server must start first? What are the components of a socket? What is a domain? What are named and NS lookup? How does recursive name resolution works? How can you connect to a server xyz.com over port number 1234? Why does FTP use more than one port numbers for communication? What are the functions of the hash and bin commands in FTP? So, with that we come to the end of today's lecture. Thank you.